Good afternoon, students. Welcome to the 51 lecture. Welcome to lecture 51 of fluid mechanics subject. In this class, we'll discuss about a new topic, that is measurement of flow, right? So in the last classes, we have completed successfully all the 3 units without any uh, balanced topics, without any small topics also. We have covered everything without any gap. So in the unit 4, we are having other types of concepts to be discussed, right? So in the unit 1, if you uh, get the information about the unit 1, so in the unit 1, we are having various types of measurement devices, right? So the various types of vacuum pressures, measurement of pressure, right? Pressure gauges, manometers, differential manometers like this. Here also, you are having the various types of devices which are used for measuring the flow of fluid. The flow of fluid may be the water, the flow of fluid may be the kerosene, the flow of fluid may be the oil, like this. So we are having various types of flows as already discussed in the unit 2, right? Various types of flows, classification of flows, right? That is steady flow, unsteady flow, like this. So in this unit 4, we are having various measuring devices, right? Their applications, their advantages, disadvantages, and their problems related to the type of flow, right? So the topics which are covered in this unit 4 are, see the first one, measurement of flow, introduction to the measurement of flow. Next, what are the various types of flows, classification of various types of flows. Okay, so in the measurement of flows, we have seen various types of flows. So in the unit 3 also, we have seen the laminar flow and the turbulent flow. In the same way, we have seen various types of flows in this unit 2. Then why the flow rate should be checked, right? Why we have to measure the flow rate? For what purpose we have to measure the flow rate? What are the applications of measuring the flow rate? And what are the various fields that are used for measuring the flow rate? We'll discuss in this topic. Next one, we'll discuss about various types of electromechanical devices, mechanical devices, and other devices where they are used for measuring the flow of liquid. That is introduction to the pitot tube. Introduction to the pitot tube. Second one, introduction to the venturimeter, right? Third one, introduction to the orifice meter. So what are these three things? These are the devices, measuring devices, which are used to check the flow rate of any fluid. So this type of devices we can see in your laboratory also. Okay, now this type of devices we can see in the laboratories. So what you can see, the measuring devices where you are calculating or checking the indication of the flow rate coming from one entry to the other level. Next one, classification of orifices. So what is the meaning of orifice? What is the meaning of notch? What is the meaning of nozzle? We will discuss in this session. That is classification of orifice. In that, what are the various types of orifices? That is small orifices, large orifices. So like this, you are having various types of orifices, the applications of orifices, and the classification of orifices. Next topic to be discussed is what is the meaning of a notch, right? What is a notch and what are the various types of notches, and how the flow of fluid is happening, how the flow of fluid is happening in the rectangular type of notch, triangular type of notch. Okay, where the flow is happening in the rectangular type of notch and the triangular type of notches. Next one, flow over trapezoidal and stepped notches. Next application of the flow is trapezoidal section and a stepped section. So overall in this unit, the design what you are discussing is rectangular type of notch, triangular type of notch, trapezoidal type of notch, and a stepped type of notches. and their applications where we are using. Next one, we'll see the introduction of broad crest vias and OG vias. So we will see various types of broad crest vias and OG vias and their applications. Like this, in the unit 4, you are having these topics to be get covered. So we will take minimum 15 classes, right, to complete these topics. Okay, now. So if you see the unit 4, so in the unit 4 you are having theory plus problems. So out of 100%, you are getting 40% of 40% of theory. Okay, 40% of theory, 40% of theory, and 60% of 60% of problems. You are getting 60 is to 40 ratio problems. Okay, right. Okay. We'll move on to the topics. So we'll today in this class we'll discuss about basic concepts of measurement of flow and the flow types. Why flow measurement? Why we have to do flow measurement? Why? Because the main purpose is to cost accounting of services. Cost of accounting of services like water, gases, and steam. So wherever the applications you are using is water application, gas application, and steam application, in order to check the cost accounting, right? If you see the real-time applications, in order to, for example, if you are having oil and gas factory, in the oil and gas factory, every time the oil and gas is flowing through the pipes. For what ultimate thing you are doing this one? For the cost accounting, for doing of the business. Next one, plant material balancing. So the plant and the material for balancing purpose you are using flow measurement. Next, for quality checking and control. Next thing is a quality control checking. We are using the flow measurement. And what is the purpose of flow measurement? What is the necessity? These are very, very important for various applications. These are very, very important for various applications which are using in the various applications like a domestic application. We are using the domestic purpose, next agriculture purpose, and industrial purpose. Apart from this drinking, agriculture, and industrial purpose, we are also using the flow measurement in various laboratories, chemical laboratories, school or college or laboratories, and we are using in various other applications like in militaries, in hospitals, right? In checking of all various types of measuring devices, right? So if you see the type of drinking purpose, we are using flow measurement. If you take an example of reverse osmosis process, RO process, ఎక్కడ విన్నారు ఈ పేరు? RO means reverse osmosis treatment plant. For example, if you see in our college, in the Chevrolet college, go to the top floor, go to the terrace and see, you can see two types of things that are installed on the terrace of the college. One is the solar panels arranged for the production of electricity, and second one is reverse osmosis treatment plant, where you can see corner of your building. There, from there, the well water is coming to the top. From there, it is getting ionized, is getting treated, and you are getting those water as drinking water in your coolers arranged in every floor. Okay, so the drinking purpose, agriculture purpose, and industrial purpose. So the RO process, in the RO process, if you see the setup of the RO process, or on the roadside, you are getting a water can, right? So there also the water is flowing in various pipes, right? You are having the valves, you are having the nozzles, you are having the orifices. The water is passing into various categories, various filters, and thereby you are getting the quality of water. So here it is very, very important to check the quality of the, to check the flow rate of the water. Next, agriculture purpose, where you are getting water for the agriculture, you are getting in two ways: naturally, artificially. Naturally means you are getting from the borewell, బావిలో నుంచి you are getting water to the agriculture, and also nearby ponds, nearby lakes, or nearby canals. There also, through the pump, through the motor, you are sucking the water and you are discharging to the crops. Then artificial one means from the water treatment plant system, from the water treatment, which are located in the outskirts of any towns or villages or in cities. There you are continuously there in the big factory, in the big plant, the water is completely recycled, right? So here, where we are getting the water to the treatment plant, so we are getting by three ways. For the water wastewater treatment plant, okay, we are getting the wastewater by three ways. First one is by sewage system, domestic or sanitary sewage system, means the wastewater coming from the houses, hotels, restaurants, shopping complex, temples, gated communities, function halls. Like this, you are getting the water from the domestic or sanitary application. Next, second one is from the industrial purpose, from the industries. From the industries, various types of industries, you are getting the wastewater, and this wastewater is carried through the sewer pipelines or industrial trucks, industrial containers, and these water are collected in the treatment plant. Next, third one, rainwater or a storm water. What is the meaning of this one? Whenever in the rainy season, whenever the rains are falling on the ground, roads, buildings, top terrace of the building, terrace of the houses, so you are collecting the rainwater harvesting chamber. So మీరు ఇంట్లో ఏం చేస్తారు? So you are making a gutter into where the water is flowing. You are making a gutter, or your hole is made. Thereby, rainwater is coming and dropping onto the whole pipe, and these are dumping into the ground where you have already set up a rainwater harvesting setup. This water is again used for your domestic applications. Like that, the municipality or the municipality corporation, what they will do, so whenever the rainwater is falling on the roads, on the streets, this water are going into the manholes. This storm water is going into the manholes or different types of sewer pipelines, right? So from this, the water is going into different channels through the sewer lines, and these are collected at a big separate sewer piping system, separate drain system. Here the water is sent to discharge to the big water bodies like oceans, seas, or rivers, or these are transported to the water treatment plant for treating the water. So like this, we are having three types of things, that is getting from the sanitary or domestic, secondly industrial water, thirdly storm water. Next one, industrial purpose. So for the industrial purpose also, we are getting two types of water. One is we can dig a well nearby or inside your industrial area, and we can get the water. Second thing, you are purchasing the water from the treatment plant. For all the industries, you are not using 100% or 90% pure quality water, right? Only in some cases like distilleries. Distilleries means where you are producing the alcohol beverages, right? Water bottling plant. In such cases, you have to take 100% pure water. But in other factories like tanneries, leather industry, like food industries, like paper and pulp industries, like sugar industries, like ceramic tiles industry, so there is no requirement of high good quality of water. A normal water is enough without salt content. So where this water is coming, these waters are coming from the wastewater treatment plant. They will purchase the water and they will use for the industrial applications. So in every factor, there is the concept of measurement of flow, right? Whenever you switch on the tap, the water is coming from the pipe to the tap outside. So there also, if you want to check the how much flow rate it is coming, you can use some sort of devices, right? So like this, the applications of the flow measurement is enormous. Okay, next one, flow measurement. Next one is a flow measurement, where these types of flows are encountered. Encountered means where you have experienced. So in the clean or dirty areas, right? Obviously, in the clean or dirty areas, we can see that these types of flows encountered. Next one, wet or dry surfaces, right? Wet surface or dry surface. Third one, hazardous or corrosive or safe conditions. Fourth one, single or multi-phase system, linear or turbulent type of systems, right? Linear or turbulent type, varying pressure type, varying temperature type, flow rates from the least to highest. Flow rates depends upon the various types of flow rates from the lower category to the higher category, right? So like this, we can encounter various types of flow rates. Next one, types of flow measurement. Types of flow measurement. First one is primary or quantity meters, positive displacement meters, secondary rate meters, and special methods. These are the various types of meters which are used for the checking of the flow of water, flow of kerosene, flow of oil, flow of some other material, right? Next, flow meters. These are the measuring devices, flow meters. What are the various types of measuring devices? The devices which are used to measure the flow rate are venturimeter, right? Venturimeter, which is based upon the pressure difference. Second one is orifice meter, which is based upon the pressure difference. Third one, rotameter, which is based upon the drag forces. Fourth one, pitot tube. Fifth one, magnetic meter, where you are using some magnetic field in order to check the flow rate of the any liquid. Sixth one is ultrasonic meter. Ultrasonic waves are used for this checking. Seventh one is turbine flow meter. So in the turbine flow meter, we are using the device called turbine for checking of the flow of any liquid. So among all these types of devices, in your syllabus, you are having venturimeter to discuss, orifice meter to discuss, and pitot tube to discuss. Among the 7 types of flow meters, you are having only 3 types to discuss, and based upon their operating conditions, their working conditions, their design categories, you are having some derivation. Based upon the derivation, you are getting some formulas. So with that, you are doing some problems, right? Next. Next, coming to the other topic is classification of fluid flows. Classification of fluid flows. The first one is viscous fluid and inviscous regions of flow. Viscous fluid and inviscous fluid. So what is the viscous fluid? The flows in which the friction effects are significant. So in the viscous type of flow, the flows in which the frictional effects are majorly observed. What are the inviscous flow regions? In many flows of practical interest, there are regions where the viscous force are negligibly small compared to the internal or pressure forces, right? So if you see the figure here, the inviscous flow region, where the flow is somewhat strong, thick here. When coming to the viscous flow region, the flow of liquid is easily moving, right? Next, inviscous flow region. So this is the inviscous flow region. From here to here, this is the inviscous flow region. Here to here is a inviscous flow region. But the gap in between the two inviscous regions, the flow is happening. The flow is happening. Slowly, this one also takes place. Slowly, this one also takes place. For example, if you are pouring any oil from one container to other container through a funnel, and what happens whenever you are flowing or whenever you are dumping the oil from one container to other container, so through an orifice or through a funnel, so at a certain correct hole, the flow will be easily flowing. But other the boundaries of the funnel or any nozzle, it will be some sort of restrictions when compared to the center axis of the orifice. That is nothing but viscous flow and inviscous flow or inviscous flow regions. The flow of an originally uniform fluid stream over a fixed plate and the regions of viscous flow next to the plate on the both sides and viscous flow away from the plate, obviously, right? Next. Next, second type of flow is internal flow and external flow. And what's the meaning of internal flow? Uh, the flow in a pipe, the flow in a pipe or duct. Okay, the flow in a pipe or a duct. If the fluid is completely bounded by solid surfaces, that is nothing but internal flow. Okay, na? It is in this the fluid is completely bounded by a solid surface. Whereas in the external type of flow, the flow is unbounded, the flow of an unbounded fluid over a surface such a plate or a wire or a pipe. So what happens here? The flow of an unbounded fluid over a surface such as a plate, wire or rope pipe. Third one, internal flow, the flow in which the pipe of the fluid is completely bounded by a surface. For example, if you see the figure here, the external flow over the tennis ball. So this is a tennis ball. This is a tennis ball. The flow of fluid, the flow of the air, external flow over a tennis ball and the turbulent wake region behind, right? So see here, the flow is passing in this direction, right? The flow is passing in this direction and it is passing on this direction. So again, it is taking the action of conical shape, right? So the water flow in this pipe, the water flow in this pipe is internal flow and the air flow over the ball is external flow. So generally example is whatever the pipe you are having in your house or in any college or school, if you see the water is flowing in a pipe, it is nothing but internal flow. It is nothing but internal flow bounded by the solid surface. So total a pipe is covering a fluid, thereby the fluid is restricted and it is passing only in that particular channel. Whereas the flow of liquid in a duct is called open channel flow if the duct is only partially filled with the liquid and there is a free surface. So there is nothing but the open channel flow. So this is the second types of flow. Next one, compressible versus incompressible flow. Next one is a compressible versus incompressible flow. So what is the incompressible flow? If the density of the flow, so you are seeing now the property of a fluid or a gas. If the density of a flowing fluid remains constant throughout the process, it is nothing but incompressible flow. Example, liquid flow, right? So for example, if you take any water in a balloon, right? So for example, see this figure. It's a Australian image of a spherical shock wave produced by the bursting balloon at the Penn State at some lab lo em chesaru, they have conducted an experiment by bursting the balloon. Several secondary shocks are seen in the air surrounding the balloon. So ఒక balloon తీసుకొని, right, balloon లోపల so shock wave పంపించి, so they have collapsed the balloon. So whenever the balloon is bursting, you can see what's happening outside at the center surface of the balloon, right? So here, if the density of the flowing fluid remains constant throughout the thing, then it's a incompressible fluid. And what is the compressible type? If the density of fluid changes during the flow. So, for example, if you take a balloon filled with air, tie it, and press in your hands, then what happens when, according to your pressure, where it is flowing, compressible, where it is uncompressible. So, according to your pressure of hands, the gas or air is escaping to other opposite sections, right? So మీరు ఒక బెలూన్ తీసుకొని సెంటర్లో ప్రెస్ చేశారనుకోండి, what happens? You can press it. Then what happens? The air is escaping from the center portion and it is filling that side end or this side end. Then it is escaping. It is compressing. Thereby, what we can say, if the density of the fluid or air changes according to the flow, example, high-speed gas flow, then we can say these are incompressible fluids. These are compressible fluids. If you see the incompressible flow or incompressible type of gas, just like a gas cylinder, here the air is totally compressed and kept in the cylinder. Next, when analyzing the rockets, spacecraft, and other systems that involve high-speed gas flows, the flow speed is expressed as a Mach number. So in other type of rocket science study, whenever the flow speed is often expressed as a Mach number, and we can represent. And what's the meaning of Mach number? MA is equals to V by C. V is equals to speed of flow. C is equals to speed of sound. So whenever the flow is happening, automatically you can listen to some sort of sound. Then speed by sound of flow. Speed of flow by sound of speed of sound. Speed of flow by speed of sound. Flow by sound is nothing but the Mach number. So whenever the Mach number is equal to 1, we are considering them as a sonic flow. Whenever the Mach number is less than 1, we are considering them as a subsonic flow. Whenever the Mach number is greater than 1, we are telling them as a supersonic flow. Whenever the Mach number is less than 1, we are saying hypersonic flow, right? We are saying them as a hypersonic flow. This is a types of compressible and incompressible flow. Okay. Next, fourth one is laminar versus turbulent flow. So we have already experienced, or we already discussed in the unit 3 the types of laminar and turbulent flows, right? Next one. So in the laminar flow, what's happening? You know that Reynolds number less than 2000, we are calling them as a laminar flow. Reynolds number more than 4000, we are calling them as a turbulent flow. So the laminar flow, what happens? Here the flow is in a straight fashion. Here the flow will be in a straight fashion, right? So the highly ordered fluid motion, the highly ordered fluid motion characterized by the smooth layers of fluid. Here, what is the type of fluid flow? Here, the type of fluid flow is very smooth. So there is no handling of a rough type of things. So here the fluid flow layer will be very smooth, so that you will not get any turbulence in any container where it is having. The highly ordered fluid motion characterized by the smooth layers of fluid, The flow of high viscous fluids. So the flow of high viscous fluids such as oils at low viscosities or velocities is considered as typically laminar. So when you are generally you are getting laminar type of flows only you can see in the oils, right? Various types of viscous oils. Next one. Second type is a turbulent flow. So the highly disordered fluid motion, that typically occurs at high velocities and is characterized by the velocity fluctuations. The flow of low viscosity fluids such as air at high velocities is considered as turbulent. And also water also you can consider as a turbulent. Third one is transition flow. Transition flow is placed in between the laminar flow and turbulent flow. So whenever the laminar flow is converting into the initial stages of turbulent flow, we are calling them as a transition flow. A flow that alternates between the laminar and turbulent is nothing but a transition flow. Now see the figure here. The flow of fluid, the flow of oil is straight line without any disturbances. If you see the turbulent flow, either in the gas or in some sort of high pressure flowing of water, high discharge of water flowing, you can see the waters are going in a different direction, different turbulent ways, right? So in between, whenever the laminar flow is slowly converting into the shape of turbulent, the sequence is nothing but the turbulent. Yes, that is nothing but the transition flow, right? So you can see the laminar transition turbulent flows over the flat plate. A flat plate means how the flow is happening. So this is the fourth type of flow where you have to calculate in the measurement of flows. Next, fifth one is natural or unnatural flow. Natural flow or unnatural flow. And what is the concept here? The forced flow or natural flow. A fluid is forced to flow over a surface in a pipe by external means such as a pump or a fan. Simple. So when you switch on the motor, from your board, the water is pumped through a force to the top tank, right? Or from a motor, a pipe is attached to the motor pipe, and when you switch on the motor, pressurely the water is coming through the motor. Then what's happening here? Some external means, in the form of electric power, that is by pump or a fan, the flow of water is with a high pressure is going on. That is some sort of external pressure, or behind the water, some means is pushing the water towards the other place. That is nothing but a forced flow. And what is a natural flow? Natural flow is due to the natural means such as a buoyancy effect, which manifests itself as a rise of warmer fluid and the fall of cooler, right? So warmer epudu thus it lighters and cooler epudu thus it denser. So whenever the changes takes place in the fluid motion or in the gaseous motion, naturally such as buoyancy effect. So if you see the image of a girl in a swimming suit, so this is a human body. The girl where she wears a swimming suit. The rise of lighter, warmer air adjacent to her body indicates that humans and warm-blooded animals are surrounded by thermal plumes of rising warm air. So if you see by the thermal scanner, so ఒక స్విమ్ సూట్ వేసుకున్న ఒక హ్యూమన్ బీయింగ్ కి, if you see in the thermal scanner, you can see some sort of flow, see here, this is a bluish color, this is a yellowish color. So swimsuit వేసుకున్నప్పుడు, because of the humans or warm blooded animals, the surrounded, what is surrounded? The thermal plumes are surrounded of rising the warm air. Why? Because the temperatures, the body is releasing some sort of temperature outside, right? Some sort of temperatures outside. Then this are nothing but a simple example of natural flow of water, natural flow of gases. That is the fifth case, that is natural or forced type of flow. Next one, steady flow and unsteady flow. Steady flow versus unsteady flow. So what's happening here? The term steady implies no change at the point of time. Steady means no change. Steady ga undante there is no change. The opposite of the steady is unsteady. So change undi ante then is unsteady. The term uniform implies no change with the location over a period of time. The term periodic refers to the kind of unsteady flow in which the flow oscillates about a steady mean. Okay, no? The term uniform means there is no change in the location. But there is, if there is ununiform, we can say there is a change in the position with the periodic, with the time taken. Okay, many devices such as turbines, compressors, boilers, condensers, heat exchangers operate for longer hours of time under the same conditions, and they are classified as a steady flow devices. Okay, steady flow, unsteady flow. If you see the figure depicts figure here, figure A and B. So the oscillating wake of a blunt-based airfoil, a blunt airfoil. This is the airfoil design. This is a blunt. This is a blunt airfoil design at a Mach number 0.6. So first photo levundi, an instantaneous image while photo B is a long exposure time averaged image. So sudden గా తీసుకున్న image is a longly taken image for long exposure, that is time calculation image. That is a steady flow, unsteady flow, right? Steady flow and unsteady flow. So in a pipe also, if you see, you are having steady flows and unsteady flows. Whenever the water is coming through the pipe, a constant velocity and constant diameter of the pipe, you can say it is steady flow. Whenever the velocity, the discharge is changing from top up to down, then automatically you can see some fluctuations in the pipe flow. Then you can say that's a unsteady type of flow. Next one, last one is a one type, two type, and three-dimensional flows. So it's already discussed in the unit 2. So a flow field is best characterized by its velocity distribution. So velocity ఎలా distribute అయ్యింది irrespective to the body, how the velocity is distributed. This will be characterized by the flow field. A flow is said to be one or two or three-dimensional flows if the flow velocity varies in one or two or three-dimensional respectively. Next one. However, the variation of velocity in certain directions can be small relative to the variation in other directions and can be ignored. Okay. Next, the flow over a car antenna is approximately two-dimensional except near the top and bottom of the antenna. So the antenna is placed here. The flow over a car antenna is approximately two-dimensional. Two-dimensional means x-axis and y-axis. Three-dimensional means x-axis, y-axis, and z-axis. Right? X-axis, y-axis, and z-axis. One-dimensional means the flow of air or fluid flowing only in one direction. Understood? So like this, we can say number of like this we can say the various types of classification of flows. Thereby, with this classification of flows, in the next session we will discuss about the various devices which are used for calculating the flow rate whenever it is passing into the devices. Right? The flow may be any one of these seven flows. It may be the constant steady flow or unsteady flow. It may be the internal or external flow. It may be the one-dimensional or three-dimensional flow. It may be the laminar or turbulent flows. So like this, these are the first classification of types of flows we'll discuss. In the next class, we'll discuss about the measuring devices, how they are giving the exact measurements or readings whenever you are doing any experiment, right? So with this, we'll stop the class and we'll discuss the next topic in the next session. Okay. So thanks for listening the class. So once the video is uploaded on the YouTube channel, I will forward the link to your WhatsApp group. Later, this will be sent to your any friends, those who are not properly coming to the class. So we'll stop here.